weekend, just we had a discussion about what is multitasking. What is multitasking? Next and after that, how many types of multitaskings are there? I want to do execute several tasks simultaneously. Execute several tasks simultaneously is the concept of multitasking. There are two types of multitasking are available. Sir, first one is process based, and the second one is thread based. Regarding process based, and the second one is thread based, right? Okay, executing several tasks simultaneously, where each task, okay, each task is a separate independent process, where each task is a separate independent process. Sir, such type of multitasking is called process based multitasking, best suitable at the operating system level. Are you getting that? Best suitable at the OS level. If you want to communicate with the processor, then this type of multitasking the people are going to use, right? Okay, each task is a separate independent process. Sir, sometimes I have only one process is there, I have only one program is there. In that program, multiple independent parts are there, okay, where each task is a separate, independent part of the same program, independent part of the same program. Sir, I have only one program is there. In that program, multiple independent parts are there. Those independent parts I want to execute simultaneously. Such type of multitasking is nothing but thread based multitasking. Remember that, sir. Sir, what is multitasking? How many types of multitasking are available? Sir, what is the difference between process based and the thread based? Thread based multitasking is the best suitable at programmatic level. Process based multitasking is the best suitable at OS level. If you want to develop applications which are going to communicate with processor, process based multitasking is a very commonly used, right? But in general, programming level, as a developer level, sir, thread based multitasking is the best choice for us, right? Okay, most of the times we are always going to use thread based multitasking. Okay, like, sir, in Python, how you can able to develop the programs? How we can able to develop the program? For that, we require to use threading is the module. All the total, the required classes, the required functions available inside which modules are threading. Threading is the module. That's why if you want to write the multi-threaded applications in Python, if you want to write multi-threaded applications in Python, compulsory we require to go for import threading, or otherwise from threading import the star, like compulsory we require to do that. From threading import the star. Okay, remember that, sir. Okay, sir, now here just take a bit very special care, sir. So from threading import the star or import threading, like we require to use. Remember that, sir. Just again I'm repeating the point. Here, legend, the people who attended last Saturday Sunday, those people only allowed to continue, because it is not the first session in multi-threading. If any persons are today is my first session on multi-threading, please log out. This batch is for 6 p.m. and 7:30 p.m. batch peoples. Okay, 6 and 8 o'clock batch people. Sir, this is the multi-threading. Already we covered in the last sessions. Okay, it is the part 2 of multi-threading. Shiv Krishna. Yeah, happily you can live and enjoy. Okay. Now here just take a bit very special care about this one, sir. So this is about okay, how, which module we require to use if you want to develop multi-threaded examples, sir. Remember that, sir. Next and after that, sir, how many ways we can create a thread? There are multiple ways we discussed, sir. We remember that there are 3 ways are there to define a thread. 3 ways are there, sir, to define a thread. Okay, what is the first way? What is the first way, sir? Creating a thread without using any class, sir. Regarding creating a thread without using any class, without using any class like this, sir. I will define some function, sir. Def f1, sir, I'm defining some function. Next and after that, t is equal to, or t1 is equal to thread of, okay, target is equal to f1, something like I'm going to do. Are you getting that? Target is equal to f1, something like I'm going to do. Here I'm not using any class, just I'm not using any class. Write a function with our required job, just create a thread object, sir, with that function as the target, and after that t1 dot start, like this you can able to do that. Are you getting? t1 dot start, like that we can able to do that. Okay, remember that this is the first way how you can able to create a thread without using any class, right? What is the second way? Can you please remind? I forgot, sir. Can you please tell what is the second way, sir? Creating a thread. Please respond. Creating a thread by extending okay thread class, by extending thread class. Sir, very simple. Class my thread, it is the child class of thread. Are you getting? Class my thread. Now I have to override run method. Are you getting? Now I'm going to override run method, right? Yes, whatever job you can define inside run method, no problem at all, sir. Sir, now, sir, I'm writing a class that extends the thread class, creating the child class for thread class. In that run method, I'm trying to take. In that run method, I'm trying to take. Now, just the biggest advantage here is create my thread object, t is equal to my thread t dot start, then automatically my thread by default is going to be started. Remember that, sir. Sir, here everything is the predefined. I mean, thread is the predefined. Next, the run method is also predefined like this, right? Okay, make sure this is what, no need of target. Correct, no need of target, because my thread can able to understand, sir, whatever run method is there inside my thread class by default, it is the advantage, right? We are not required to provide target is so and so on, right? Okay, this is creating a thread by extending thread class. Sir, now I didn't extend thread class, right? Okay, creating a thread without extending thread class, without extending thread class, right? Okay, creating a thread without extending thread class, what we require to do, the very simple, sir, very simple. Just observe that normal class. I have normal class is there, f1 is there. Okay, in that just I'm writing some job, sir. Just aware, I'm writing some job like this. Now t is equal to, can you please create thread? Sir, here I'm depending on thread directly. Compulsory we require to pass target is equal to some f1 or something, like we require to pass, right? Okay, target is equal to some f1, like this we require to pass, like this way is nothing but third way of creating a thread. Up to this any doubt? Okay, like this we require to do that. Yes, obj is equal to test and so on, obj is equal to test if it is, and then obj dot f1, like this we require to call something like this. We covered already all these things with the examples. All these things already we discussed with the examples, right? So in how many ways we can define a thread? Yes, I covered, right? Next, and after that, without multi-threading, with multi-threading, we discussed already, right? Without multi-threading, with multi-threading, what is the difference already? With the multi-threading, the biggest advantage is we can able to complete the total task easily within the less time. So automatically, performance of the system by default is going to be improved, right? That's what you people should aware. Next, after completing that, how you can get and set name of a thread? How you can get and set name of a thread? For every thread, default name is available. Okay, if you are not going to provide, my Python virtual machine itself is going to provide default names. For every thread, some name is available. How you can get the name? Okay, t dot get the name is a method you can use. T dot get name, or otherwise t dot name property also you can use. Yes, both are the same. T dot name property also you can use, or t dot get name. Sir, in both cases we are going to get name of that thread. Remember that, sir. Sir, I'm not satisfied with the default names. I want to set my own name. No problem at all. T dot set a name. Are you getting? Sir, I want to set my own name. Then automatically t dot set name. Sir, whatever name you want, happily you can able to set, sir. Next, if you want to get a current thread object reference, can you please tell how I can get current executing thread? Can you please tell how I can get current executing thread? What is the method we require to use? I forgot. I want to get current executing thread. Then automatically current thread. Like this we require to use. If I can use current thread, then what will happen is, if I use current thread, then automatically we are going to get current executing thread. Remember. Okay. Next, and after that, even thread identification number is there. For every thread, there is some identification number is there. Maybe to identify the threads we may use. Yes, how you can able to get current, thread identification number is T dot IDENT. Are you getting? Sir, IDENT is the attribute, is the property, is the variable. Okay, if you can use this one on the T, then automatically you people are going to get sub thread identification number. Remember that, sir. Next, and after that, how many active threads are there? How many active threads are there? Just we use the active count is the method, right? Next, after that, sir, I want to know all active threads information. Then automatically enumerate the function. Are you getting? Enumerate function we require to use, right? Okay. Next, I want to check if the thread is alive or not. Array, the thread is live or dead. The thread is live or dead. Then automatically we should go for. Then automatically we should go for is alive. Okay, like sir, I want to wait. I want to wait until completing some other thread. I want to wait until completing some other thread. Then automatically join is the method we require to use. Regarding I want to wait until completing some other thread. Then automatically join itself is the method we require to use, right? Okay. Sir, next, yes, next concept, what the thing we require to discuss, right? Next terminology, what we are going to discuss. Observe a bit very carefully about this one, sir. Sir, what is the next one? Daemon threads. Even we discussed this part also in the last session. Daemon threads. Can you please tell what is the daemon threads are? The threads which are executing in the background. The threads which are executing in the background. The background executing threads are by default considered as daemon thread. How you can check whether the thread is the daemon or not? Sir, very simple. T dot is a daemon. Are you getting that? What the method we have? T dot is a daemon, or T dot simply if you want a daemon nature, daemon like this. Is a daemon or daemon we require to use, right? Okay, is a daemon or daemon we require to use. Sir, I want to change the daemon nature. No problem at all. Sir, you can go for set daemon. True, you can take. Okay, then automatically now the thread by default daemon nature will be changed. But make sure, sir, we can change daemon nature of a thread by using set daemon method. But make sure set a daemon method, okay, we can call before starting of a thread only. Once a thread is started, we are not allowed to call this method. Okay, remember. But main thread by default already started. That's why. So it is not possible to change the daemon nature of main thread. Main thread is always non-daemon only. Remember that. Sir, what is the main advantage of daemon thread? To provide support for non-daemon threads. To provide support for non-daemon threads. I told, right, heroine is there. Sir, makeup person is required. Okay, like supporting persons are required. Those supporting persons to the heroine or hero, these supporting people are by default considered as daemons. Okay, once last non-daemon thread terminates, automatically all the daemon threads by default will be terminated. Next, by default main thread is always a non-daemon. The remaining threads daemon nature is inherited from parent to child. That's it. That is the part what we covered in the last week. Correct? Up to that we completed, right? Now I hope a small revision also happened for you people. Clear, right? Okay. Now, what is the next cinema we ready to start, sir? A bit more important concept. Dangerous concept. Better to listen with fresh mind. A bit dangerous concept we are going to discuss. Synchronization. The people who are coming from Java background, they can able to understand very easily, right? Okay, very easily they can able to understand synchronization. Remember that, sir. What is the synchronization? What is the need? What is the need of synchronization, right? Very simple terminology, sir. Listen. What is the need of synchronization? Best example. Okay, do you know if multiple threads are going to operate simultaneously on the same object? Remember this, sir. I have some object is there, sir. Some object is there, sir. If multiple threads will operate simultaneously, on the same thread object, are you getting right? Then there may be a chance of data inconsistency problems. Correct, right? One thread trying to add something, another thread trying to remove something, another thread is trying to remove. Like if multiple threads are going to operate simultaneously, then there may be a chance of data inconsistency problems. Remember this one, sir. So best example for you, just aware a small funny example. Even in my Java classes also, usually I covered. Okay, like do you know, in our villages especially, how many people came are from the village background? Can you please respond? How many people came from the village background? Yes, in the villages especially, do you know, sir, what happened is, just assume these scenarios are very common in the villages. Okay, sir, I took biryani, but I didn't feel that, sir, biryani is not that much good. What I did is, I throw that biryani plate, sir, to the dustbin, or to the dustbin which is there on the roadside. Are getting at the roadside, there is one small dustbin, something public the dustbin or like will be there. Just I throw that. Whenever I'm throwing, then automatically one dog saw that. One dog saw that biryani. That one dog saw that situation, right? Now observe this. This is the biryani plate. Of course, here this is the biryani plate. Just assume the small pieces also available, right? Okay, like there are small biryani places, pieces also by default available. This is the biryani plate. What we have assume that, sir, I throw this biryani plate to the dustbin. I didn't feel that much happy. Assume that, sir, the taste is not that much good like this. Next, now what happened is, whenever I'm throwing this one to the dustbin, immediately one dog saw this biryani plate. Are you getting that? One dog saw this biryani plate, right? Okay, assume that. Whenever dog saw this biryani plate, then immediately dog felt very happy, because usually human being, whenever you want biryani, either Sunday or otherwise, there is immediately will go to the hotel, or otherwise you can prepare on your own. You can eat. But dogs not having such type of facility. Are you getting that? Not having such type of facility. Okay, then what happened is, sir, this dog saw that biryani plate. It felt very happy, sir. It came. Then it is observing how many pieces are there and so on. Now, whenever this dog observe this one, suddenly assume that another dog also came, sir. Suddenly assume that another dog also came. Assume that, sir, another dog also came. Sir, whenever another dog came, are you getting? Whenever another dog came, then immediately what is the next situation? Can you please guess what the next one is going to be happen? Okay, definitely fighting is going to be happen, right? Meanwhile, one more dog came. Meanwhile, one more dog came, sir. Observe that one more dog came. Sir, do you know, sir, this dog also came, sir. Now assume that this dog also came, sir. Then every dog is going to fight with the remaining two dogs. Every dog is going to fight with the remaining two dogs. The main intention is, if the remaining two dogs will go happily, the current dog happily can able to eat. Are getting? If the remaining two dogs will go happily, the remaining dog happily can able to eat. Like that, every dog is going to fight with the remaining two. Sir, the people who are coming from village background, you in your mind already you have this type of scenario several times. Correct? Are you in a position to visualize the situation? Yes, man. The dogs, then automatically we have to keep a big stick, and then we will go. All the three dogs will give left and right, because the sound is disturbing like anything. Are you getting? Sometimes it's very common. Now assume the whenever this dog is going to fight with this, if this dog is going to fight with like this, then immediately these three dogs are full busy in the fighting. Meanwhile, a bit intelligent dog came, sir. Assume that one more dog came. Then what this dog is doing is nothing more. It start eating from this side. Whenever this dog eating from this side, worry about feeling of these three dogs. Already they are fighting to get the chance, but this person start eating. Then immediately the dogs decided, "Arey, there is no use of fighting. There is no use of fighting." Then automatically, so we have to eat as much as possible. This dog is going to pull like this dog is going to pull from this side, this dog is going to pull from this side, this dog is going to pull the biryani plate from this side. What will happen, sir? If all the dogs operate simultaneously on the same biryani object, then there may be a chance of data inconsistency problem. Are you getting? This problem is nothing but what? Biryani inconsistency problem. Are you getting? So what will happen? Every dog is trying to pull, then that biryani will become waste. No dog is going to eat. Correct? Correct? Are you able to guess? Yes. Are you able to visualize? Okay. Sir, here how many biryani plates are available? How many biryani plates are available? Only one. But how many dogs are available? Multiple dogs. If multiple dogs operate simultaneously on the same biryani plate, then there may be a chance of biryani inconsistency problems. Biryani inconsistency problems may be a chance. Remember this one, sir. So here that biryani by default will become waste. So no dog is going to eat properly. There may be a chance of this problem, right? Clear, right? Okay. Sir, this is one very, very dangerous scenario. Sir, where if multiple dogs are going to operate simultaneously on the same biryani object, maybe a chance of sir biryani inconsistency problems are going to come. Sir, just let me bring into the original, let me technical terminology. I have one Java object is there, sir. I have one Java object is there. Sir, now, sir, if multiple threads, sir, not Java, Python object. Don't get confused. Sir, multiple threads are going to operate simultaneously, sir. Simultaneously, there one thread is trying to add something, another thread is trying to remove something, another thread trying to delete something, maybe a chance of data inconsistency problems. Are you getting right? So to overcome this problem, we should go for synchronization. To overcome this problem, we should go for synchronization. Synchronization means at a time only one thread. Remember that. At a time only one thread. Sir, first thread came. Assume that first thread came. Sir, first dog came. First dog starts eating. No problem at all. Once the first dog completed, then only second dog is allowed. Are you getting that? Then only second dog is allowed. If a second dog came in the middle, simply, hey, please wait, first dog is currently eating. Once the first dog completed, then only you will get the chance. Like, sir, this second dog is going to wait. Once the first dog completed, then only second dog is going to start. Once the second dog completed, then only third dog is going to be, sir, starts its execution. If all the threads are going to execute one by one, then automatically there is no chance of data inconsistency problem. Correct or not? Yes. Are you able to understand? Okay, make sure at a time, how many members are allowed to access? Only one member. Okay, sir, let me go to technical examples where you have this type of requirements, right? Observe that. Suppose, sir, it's a very common requirement, reservation systems, online ticket reservation system, maybe bus ticket, train ticket, or otherwise movie ticket reservation tickets. Are you getting it? Ticket reservation system. It's a very common best example, sir. Suppose assume if 4 tickets are available, sir. If 4 tickets are available, one person, yes, book my show, next book my ticket, book my show, IRCTC, like there are like multiple online ticket reservation systems, right? Redbus.in, like sir, T1 is there. Next and after that T2 is there, like sir, total 4 available tickets are there. T1 requested 3. Okay, yes, 3 tickets are available. That's why it is going to be processed. Meanwhile, T2 also requested 2. Okay, both the said yes, 2 are available, 3 are available. If both the people are going to send the request simultaneously, if the request is going to be processed both simultaneously, then may be a chance of problem. Correct or not? Then there is a chance of problem. Sir, these things should be, sir, these threads should be these threads should be executed one by one, one by one. Sir, first who came, either T1 or T2, first that person request by default will be considered. After completing that request only, this person request by default, this person request is going to be considered, sir. Observe a bit very carefully about this scenario. Clear, right? Any doubt regarding, sir? Sometimes, you know, in the festivals, festival days, especially in India these days, anyway, a bit this problem got solved, sir. Festival days, festival days, if you are going, if you want to travel to your native place, regarding, right? Are one ticket only, one seat only, but these travel people are going to, sir, give the ticket for the same seat, two or three members. Then may be a chance of fighting about that seat in the bus. Are getting right? Or otherwise extra chair or something like they will arrange in the middle. Yeah, can you please adjust like that? So festival days, if you want to travel to your native place, these type of problems will come because only one ticket, only one chair, but multiple people they are going to allow. Then there is a chance of big fighting. That problem is nothing but data inconsistency problem. Are you getting that? Okay, like at a time only one person is allowed to operate. If you have such type of requirement, better to go for what? Synchronization concept. Clear? Are you able to understand, right? Sir, another best example, another best example, if you want, sir, assume that this is a very common example to understand this one, sir. Do you know what we call joint account? Joint account. Do you know common joint accounts, sir? Sir, wife and husband having the joint accounts. Remember that. Assume husband and wife and husband having the joint accounts. Sometimes it's a very common, very dangerous, man. Don't implement this type of joint accounts in your life. Otherwise, your life by default will become very horrible. Remember. Here, just observe, wife and husband both are software engineers. Both are software engineers. Almost every month 1.5 lakhs. 1.5 lakhs is going to be credited to the joint account. Assume that. What happened is, sir, morning at 9 o'clock, wife checked account balance is nothing but almost 90,000 is there. Like assume that, sir, wife went to the shopping, sir. Morning at 9 a.m. wife started shopping. Then automatically, sir, going on. Bill time is nothing but around at 9 p.m. Assume that. Yeah, around at 9 p.m. 9 p.m. bill time. Whenever she sir bill, whenever she's giving the bill of almost already she did 85,000 shopping, 85,000 rupees shopping. Assume that because she knows that already account having 90,000 rupees, she did almost 85,000 rupees. Assume that. Then automatically, do you know? Meanwhile, what happened is, sir, this husband in the afternoon time he made a transaction. Sir, he sent some 20,000 rupees to his friend. Yeah, online transfer. Then automatically at 9 p.m., sir, she is trying to pay 85,000 rupees from the debit card, from the card ATM card, but that card doesn't have the money. Are you getting that? That card doesn't have the money. Then automatically the war is going to start. Are you getting that? Minimum the effect, the minimum 3 months minimum will be there, sir. Okay? Are you getting? So that's why take a bit. Here the problem is, first transaction started at morning 9 o'clock. Assume, sir, this transaction, this thread continued until 9 o'clock. Meanwhile, in the middle, husband came. Then automatically, do you know, sir, he updated, he withdrew 20,000 rupees for his own purpose. Are you getting that? Then automatically, while one thread operating, the other thread trying to modify. Because of that modification, first thread is going to be affected or not? Yes, this type of cinema is nothing but inconsistency problems. So, you know, in the database terminology, we can use the word dirty read problem, not a dirty picture, sir. Dirty read problem, something like in our database related terminologies, we are going to use these words. Correct, right? Ayo, respond, man. Multiple examples I'm covering so that you people can aware where exactly synchronization will come in the picture. Sir, if multiple threads operating simultaneously, then there may be a chance of inconsistency problem. To overcome this problem, we should go for what? Okay, synchronization. Sir, what are various synchronization mechanisms are there in the Python? I will discuss. Sir, with example, I will show a small inconsistency, sir, so that, oh, this is the problem. To overcome this problem, we should go for synchronization. Like that, right? We are going to discuss. Okay, just observe that. Assume, let me go for a small chota example, sir. Parsade, do you have any conclusion from this example? Just make sure good programming practices. Never recommended to maintain joint accounts. One thing, otherwise our life will become very horrible. Next and after that, don't go to the shopping with ladies, okay, with your girlfriend, with your wife, or with your mother and father. Automatically your life by default will be gone. Good programming practices especially, okay. Like, yeah, now just take a bit very special care about this one. Let me go for a small chota example. Just kidding sir, don't take serious. Manisha, Arpita and Vijaya, there are several, they may have full angry on me, I hope. Okay, now just observe that sir. A small example I'm taking. Sir, if multiple threads are executing simultaneously, then there may be a chance of, then maybe a chance of data inconsistency problems. Just make sure, sir, what that problem. I will go for a small chota example so that you people can feel more comfortable. Just observe that, sir. From threading, import start. From threading, import star. Okay, like, not required to keep any explanation. Even I'm taking import time module also. Okay, we know that, don't worry sir. Sir, I'm taking a small function, wish function, def wish function, just a name, sir. Sir, to whom you have to wish, like this, sir, wish function is there. It is going to take name as the argument. Just observe that, sir. For okay, I in range of 10, sir. For I in range of 10, what I'm trying to take here is just a print, sir, good evening. Regarding just a print, good evening, like this I'm trying to print. Next, end is equal to nothing. End is equal to empty, because, sir, good evening, and then I want name in the same line. That's why, so don't go for next line, like this I took, sir. Next, after printing good evening, just I want to sleep for some 2 seconds time. Assume that my thread slept for 2 seconds time. After that, print of name, sir. Remember this one. After that, print of name. Now take a bit very special case, sir. Sir, def wish of name. Sir, there is one wish function I'm taking. For I in range of 10, good evening. Sir, how many times this body will be executed? Can you please tell? How many times this body will be executed? Anyone, can you please tell? 10 times. Are you getting 10 times? Every time, what it is doing? Good evening, sleeping for 2 seconds, After that name, after that print name, good evening, sleeping for 2 seconds, name, and then again. This cycle by default will be repeated. Sir, 10 times. Observe that, sir. Sir, let me save this code. Yeah, the test.py, like this I'm taking, sir. Yeah, the test.py, like this, right? Sir, now let me go for, okay, sir, let me execute this code anyway. 1 minute. I have to call this wish function, sir, just like a normal function I'm calling. I'm not implementing multi-threading concept. Don't worry, sir. Just as a normal function, I'm calling wish of Durga, like this I'm taking, sir. Now observe a bit carefully. What is the answer by default we are going to get, sir? Py test.py. Are you getting py test.py? Yes, sir. It is going to print good evening, sleeping for 2 seconds. Good evening, sleeping for 2 seconds. Are you getting, sir? 1 minute. Where I kept a sleep method? For first, it's going to print good evening and then sleep. Correct. Good evening. What? Yeah. Correct. It is not happening. Maybe time that sleep is not working. Some 5 seconds I'm taking. Sir, 5 seconds I'm taking. First, it has to print good evening. Correct, right? Good evening. And then it has to sleep for 5 seconds. After 5 seconds sleeping, now the name has to print. Correct, right? After that, immediately again, good evening. Okay, like, no, why it's taking sleep at the beginning only? No, it is not happening as per our requirement. Okay, don't worry. Maybe what I will take is, let me start a thread. Let me start a thread. Okay, like this. Let me start a thread. Time dot sleep only. Here thread dot sleep is not there. Vaibhav. That is the Java code. Thread dot sleep. Here time dot sleep. Sir, now here just I will show. Maybe the problem with the system or something like. Let me start a thread. Just observe that. T1 thread of T1 thread of target is equal to wish. Target is equal to wish. Sir, I want to call wish method. Next, args is equal to like this. Have you remembered, right? Args is equal to, sir, what is the argument I want to pass? Assume that Dhoni, like this I'm passing, sir. Dhoni, like this I'm passing, sir, like this is like. Now P1 dot start. Oh, I'm not calling. I'm not calling. My thread is calling. My thread. I'm starting the thread. That the thread is the responsible. That the thread is the responsible to do this one, sir. Now have a look once. Have a look once. Good evening. Arni, if the thread is going to call, it's responding properly, man. Good evening, Durga. Good evening, Durga. Okay, like it's going to print. It's going to print, man. Sir, is it our expected answer or not? Yes. Sir, every time. Oh, no, 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 no. Again gone. Again gone. Again gone. This is not my expected answer. Again gone. Yes. Okay. Sir, why the problem with my system? Yes, multi-threading. Not a bug in Python, man. Every time parts are there. You are trying to blame Python. Eh? Okay. Yes, actually, sleep method is not responding properly. If it is not going to respond properly, then our life will become very horrible. Mm-hmm. Very horrible, because you can't see the impact very, very clearly. Okay. Yes. Okay. Well, okay, no problem. Sir, anyway, sleep is affecting or not, don't worry. Just I can able to show. Here the problem in your system, I'm sure, sir, you never going to get this problem. Just don't worry. Here just observe that other than main thread. Observe a bit very carefully my words. Other than main thread. How many threads are there? How many threads are there? Yes, other than main thread. How many threads are there? Only one thread. Are you getting only one thread? Only one thread. Sir, that thread is the responsible to print good evening, and then sleeping for 5 seconds, and then printing the name. How many times it's going to be happen? 10 times. Are you getting 10 times is the responsible? Now, sir, here synchronization is not required, because the reason is only one thread is there. That thread is the responsible to execute which method. That thread itself is the responsible to execute this which method. That's why, sir, only one thread. Synchronization problems, I mean data inconsistency problems won't come in the picture, because the reason for that is only one thread. If multiple threads are there, there's a problem. Suppose assume that if one biryani plate is there, sir, only one biryani plate and only one dog. Are you getting that? Only one biryani plate, only one dog. Only one dog is there. Assume that, sir. If only one dog and only one biryani plate, sir, inconsistency problem won't come in the picture. But if multiple, only one biryani plate, but multiple dogs are available, multiple threads are available, maybe a chance of inconsistency problem. Correct, right? Okay, sir, make sure. Now what I'm trying to take here is observe a bit very, very carefully about this one, sir. Now, yeah, Arpita, not required, just I can able to explain here. See, now I'm taking one more thread, sir. One more thread. Yes, target is equal to wish method. One more thread, target is equal to wish method. Instead of Dhoni, I'm taking, sir, Kohli, like this I'm taking, sir. Instead of Dhoni, I'm taking Kohli like this. Now T1 dot start, T2 dot start also. Can you please guide how many threads are there? Please respond. How many threads are there? Two threads are there. Of course, other than main thread. Forget about main thread. Other than main thread, how many threads are there, sir? Two threads. Two threads. Both the threads are executing wish method simultaneously. executing which method simultaneously. Whenever main thread is in sleeping, whenever one thread is in sleeping, the other thread trying to print something. Are you getting? Whenever one thread is in sleeping, the other thread trying to print something, then automatically which causes inconsistency problems. Which causes inconsistency problem. Now observe why this sleep method is not responding properly. Every time it's going to work. No, 2 seconds, 5 seconds, like every time it's working, right? Okay, now have a look once. Have a look once, sir. Yes. Okay, have you observed? First thread is in sleeping. Immediately second thread also started. Regarding immediately second thread is also started. Then automatically, have you observed, right? Good evening, Dhoni, good evening, Kohli. Next and after that, good evening, like both the threads are going to execute simultaneously. Regarding both the threads are going to execute simultaneously, then may be a chance of inconsistency problems. Remember this one, sir. Then there is a possibility of inconsistency problems. Actually, not this much cute also. The output is not this much like this also. Sir, good evening, Dhoni, Kohli, something like irregular output by default we are going to get. Because the reason for that is both the threads are executing which method simultaneously. Correct or not? Respond. Both threads are going to execute which method simultaneously or not? Yes. Okay. So because of that, maybe a chance of data inconsistency problems. Remember that, sir. So now my requirement is, boss, until completing first thread, don't execute second thread. I want to convey. Array, until completing first thread, second thread should wait. Until completing first thread, second thread should wait. Okay. So until completing this for loop, not remaining code, only this for loop. Until completing only this code, remaining thread should wait, or this code should be executed by only one thread at a time. If you can able to implement such type of mechanism, then sir, the problem by default will be solved. Remember that. Why the difference between join and this I will explain. Don't worry, just observe that. Sir, this for loop should be executed by only one thread at a time. Correct or not? This for loop should be executed by only one thread at a time. At a time, only one thread at a time, right? If you implement such a type of mechanism, then automatically data inconsistency problem by default will be gone, sir. Remember that, okay? Sir, how you can implement at a time only one thread? At a time only one thread, okay? At a time only one thread, okay, is nothing but synchronization. Remember that. At a time only one thread is nothing but synchronization. Join method is the different, synchronization is the different. We will come up with that first event. At a time only one thread, then we should go for synchronization concept. Sir, in Python, how you can able to increment, how you can able to implement synchronization? There are three ways are there, sir. One is lock concept. One is lock concept. Second one, sir, RLock concept. Okay. Second one, RLock concept. Third one, sir, semaphore concept. Are you getting? Semaphore concept. Sir, total how many ways are available, sir? Three ways. What is the first way? What is the first way, sir? What is the first way? Sir, now lock concept, RLock concept, next and after that semaphore concept. By using these three mechanisms, we can able to implement synchronization in Python. R means re-entrant. Remember that even in Java also it is there. Re-entrant. Re-entrant means again and again. Okay, we will discuss. Don't worry, sir. RLock, normal lock, RLock, and then semaphore concept. Okay, by using these three, we can able to implement synchronization concept. Clear, right? So now some people are asking, why don't you go for join method instead of synchronization? Yes, for them, just observe that. I have def which function is there. Just a legend a bit very carefully about this one, sir. Sir, def which function is there? Which function is there? This which function contain almost, do you know, here 1 lakh lines of the code is there. Assume that 1 lakh lines of the code, and some important code, which should be executed by only one thread, which should be executed by only one thread, which should be executed by only one thread, okay. Next, another 1 lakh lines of the code is there, sir. Another 1 lakh lines of code is there. Assume that, sir. Sir, total, how many lines of the code, sir? This 1 lakh, and then some code here, and then some code here. Like, but this code only should be performed, should be executed by only one thread at a time. Remember this one, sir. This code should be executed by only one thread at a time. The remaining lines can be executed simultaneously, no problem at all. Something like in your book my show. Sir, first I want to check availability. Available. How many tickets are available? I want to check. It is simply read operation. Are you getting it? Simply read operation. Any number of people can able to perform. Need not to perform one by one. Sir, either train ticket is available or not. I want to check. I'm not going to book. Just I want to check either train tickets are available or not. If you want to check whether the train tickets are available or not, okay, or not, read operation, any number of people are allowed. Something like it is the read operation. But this is update operation. Are you getting? This is something like a read operation. This is update operation. This one is nothing but update operation. Assume again this one is nothing but read operation. Have a look once. Sir, a big huge code is there. Sir, first thread, assume calls wish method. First thread calls wish method, right? Sir, second thread also calls wish method. Sir, maybe a chance of inconsistency problem because this code executed simultaneously by both the threads. Are you getting? Maybe a chance of inconsistency problem because this code executed by both threads simultaneously. Someone suggesting, sir, why don't you go for T1.join? Are you getting? Someone suggesting, why don't you go for T1.join? The problem here is, if I use a join method, sir, second thread has to wait until completing total. Are you getting? Until completing total. But this part under this part can be executed simultaneously, no problem for me. Are you getting? No problem for me. Why? I have to wait until completing first thread. Until completing. Sir, I want synchronization only this particular middle part only. Are you seeing the difference, right? If I use a join method, what will happen? If I use a join method, what will happen? Sir, until completing these 2 lakh plus lines of the code, second thread has to wait. But I don't want to wait. Sir, what is the need? It can be executed simultaneously. Unnecessary performance is going to be down. That's why wherever synchronization is required, there only we have to implement that, not for total method, not for total class. Clear? So why join method is not recommended to use. I hope everyone can able to understand, right? Okay, that's all. The people who suggested join is not recommended. We should go for synchronization concept only. Observe that. So now, in how many ways we can implement synchronization? Okay, in how many ways we can implement synchronization? Okay, like 3 ways. What is the first way, sir? Lock concept. Second way, sir, RLock concept. Third way, sir, semaphore concept. Okay, let me go for synchronization by using lock concept. Synchronization by using lock concept, right? Okay, very simple terminology, sir. What we will do is, sir, in Java we have synchronization method. In Java we have synchronization method and so on. But in Python, we are not having any synchronization method. Remember that. We never going to declare any method with a synchronizer keyword and so on, because such type of modifiers concept is not there in the Python. You know, synchronize, final, public, private, such type of terminology we are not going to declare. We have lock, RLock, semaphore concept only. Remember that, right? Okay. Sir, now how you can able to do? Sir, locks concept is the most fundamental synchronization mechanism provided by threading module. Remember this one, sir. Lock mechanism is the most fundamental synchronization concept provided by threading module. Remember that, okay? So first question, how you can create a lock object? I want to create a lock object, sir. Very simple. L is equal to lock. L is equal to lock. I'm creating lock object. Okay. So now that lock object can be held by one thread at a time. Remember this one, sir. So I created one lock. Best example, sir. Public telephone booth is there. Just visualize once. Public telephone booth is there. There is a small cabin is there. Everyone is going inside that cabin. And then, sir, they are going to talk. Once the first person completed talking, then only available for the second person, available for the third person. Assume that it is inside a box. Yes, assume it is inside a box. Assume that here public telephone booth is available, phone is available. Here, some door lock concept is there. Assume that, sir. Sir, some lock concept is there. Assume like this, sir. Here door compulsory. There is some lock is there. The first person who came, he got the lock. Then happily he is allowed to use this phone. Assume that meanwhile second person is coming. Second person not having this lock. This lock is already acquired by first person. Until first person releases the lock, the second person should wait. Sir, until two persons releases the lock, third person should wait. Are you getting right? So I will have some lock. That lock object, which thread acquired, only that thread is allowed to execute that code. Remember this one, sir. Only that particular thread is allowed to execute that code. Once, sir, that execution completed, then it's going to release the lock. Then only remaining thread is allowed to execute that. Very simple, sir. So first question, how to create such a type of lock object? Can you please read once? What is the code? L is equal to? Please read. L is equal to lock. Are you getting? L is equal to lock. Now here one thread came. Sir, I want lock. Very simple. L dot acquire. Are you getting? What is the function, sir? Can you please tell? L dot acquire. Lock is a class. It is the constructor call. We are creating an object for the service. Lock is a class name. We are creating an object for that class. Lock object I am creating. Next, if a thread requires the lock, then automatically it is going to call L dot acquire. Are you getting? L dot acquire. Next, sir, it is performing sir, synchronized operations. Synchronized operations means the operations which are performed by only one thread. Do you have some code like that? The operations which are performed by only one thread. That operation we are going to do that. Sir, once that operation completed, now L dot release. Are you getting? L dot release. Remember this one. L dot release. Like so, how to create lock object? Can you please tell? How to create a lock object? L is equal to lock. Next, I want this lock. Boss, I want to execute that code. Oh, you require execute. Please take this lock. Okay. Now thread got the lock. Once a thread got the lock, then happily this code will be executed. Once this completion, then it is going to release the lock. Now observe that. Assume it is there inside which method. Assume that this code is there inside which method, sir. So T1 and T2, both the threads came. T1 and T2, both threads came to execute this code. Assume first T1 came, sir. Oh, T1, L dot acquire. Oh, to execute this, lock must be required, right? T1 got the lock. Assume because this lock is vacant, T1 got the lock. Once T1 got the lock, happily, do you know, sir, T1 starts execution of this code. Meanwhile, T2 also came. T2 observed that, oh, it required lock. But that lock is not available. That lock is already acquired by T1. Then what the T2 is going to do? T2 will wait. T2 will wait. Sir, until what time T2 will wait? T1 releases the lock. Regarding once T1 releases the lock, then only T2 is going to get that lock, then only T2 is going to execute this operation. Sir, this code is by default considered critical section. Are you getting? This critical section can be executed by only one thread at a time. If you have any code, sir, this code should be executed by only one thread. That code we can take in between L.acquire, L.release. Clear for all of it, right? Sir, can you please tell, this code will be executed by how many threads at a time? Respond. This code will be executed by how many threads at a time? Only one. Which thread will execute that? Which thread will execute this code? The thread which got this lock object. The thread which got this lock object, which acquired the lock object. Sir, now at a time, this lock object can be acquired by how many persons? Only one person. Remember, only one person. That's why, sir, this code will be executed by only one thread at a time. Remember that, sir. Okay. So the biggest advantage, inconsistency problems we can able to solve. Any doubt? Any doubt? After acquire and before release is termed as critical section. Yes, yes, sir. This code is by default considered as critical section in the operating system related terminology. Don't worry, some code which should be executed by only one thread at a time. Clear? Can I convert into example? Because if you are not going to get lock concept, then semaphore concept and RLock concept is not that much easy. Because we know in the multi-threading, dangerous concept we are discussing. Yes, remember. Sir, if you got the lock for the survey, you got the lock, but you are not going to release. If you are not going to release, then automatically, so that lock is not available to the remaining people. All the remaining people should wait until this person releases the lock. Regarding, it's always a performance problem. So that's why once your job completed, immediately you require to release the lock. Good. There are multiple doubts the people are, sir, rising. Yes, good. 1 minute. Yeah. Well, Amit, we will go for a small example. Yes, we can create this lock object globally. No problem at all. You can create this lock object globally. Under this line, we can take inside a method. Once I'm going for a small example, then you will get much clarity. Acquire and release combination mandatory. Correct, man. If you are not going to release, just you acquire and then you can sleeping, then the remaining people will be affected. That's why you should release. Correct. Okay. Then automatically if T1 acquired the lock and then session killed, means what will happen? Nothing. Then automatically the program got stuck. Only one solution, restart. How a thread will get the lock? Good. If what is this line? Jaypal Reddy. What is this line? L.acquire. Are you getting? This line executed by which thread? This line executed by which thread? That thread will get this lock. Remember that. This line executed by which thread? If a thread executes acquire method, acquire method, then automatically the thread will get the lock. Okay, calling acquire method is nothing but getting the lock. Yes. If you are not going to release, error is not going to be happen. Error is not going to be there per se. But the problem is all the remaining threads should wait. I will show that. I will show that. Keep on, like if it is not going to be released, what will happen like? Okay, like clear for all of it, right? Next, anyway, sir, we got in the here, sir, time dot sleep and so on, not that much responding, not that much properly. Have you observed, right? Okay, take a bit very special care. If any mismatch is there, we will discuss this problem. 1 minute before implementing, let me. Yeah. So now take a bit very special care about this one. Yeah, here just observe what I want to do is the people where we have to create the lock and so on. Just have a look once. I created a lock here. I created a lock here. Next, these 1 lakh lines of the code will be executed by how many threads? Can you please tell? It is just read operation. Any number of threads are allowed, right? That's why we are not required to worry. But this code should be executed by only one thread. That's why here I'm taking L dot acquire. L dot acquire. Okay. Now the thread which reaches this line, that thread is going to get the chance. Once the person who got the chance, sir, he is going to execute this code. What about remaining? All the remaining people should wait. All the remaining people should wait. Okay. Next, once the first person, sir, completed, then automatically he is going to call what? Release. Regarding first person completed, automatically is going to call what? Release. Remember this one, sir. L dot acquire, L dot release. Once this person release, then only this lock is available for the next person. Like, sir, like after completing, sir, this code will be executed by any number of threads simultaneously, no problem at all. This is something like, assume that, sir, there is a big highway is there, sir. Assume that, sir, there is a big highway is there, sir. Assume, sir, here there is a big road is there. Okay, here multiple vehicles can travel. Multiple vehicles can travel simultaneously because it is 6 lanes or 8 lanes, like no problem. Like, but at certain point, there is a small narrow bridge is there, sir. Assume that there is a small narrow bridge is there. On this bridge, at a time only one vehicle. At a time only one vehicle. Do you know? Sir, multiple vehicles can come. Multiple vehicles can come. But only one vehicle will go. After completing first vehicle, then only second vehicle. After completing second vehicle, then only third vehicle. Are you getting that? Then only third vehicle. Next, once this bridge completed, what about remaining scenarios? In the remaining, any number of vehicles can travel, no problem at all. Now, this is the line what I have to use L dot acquire. Are you getting? L dot acquire. Next, this is the line what I have to do here L dot release. Remember this one, sir. L dot release. This is the line what I have to use. Everyone can aware at least now the basic idea? Yes, man. Yeah, something like toll gate. Are you getting? Good. Something like toll gate. Multiple vehicles are going to come. Only one toll gate counter is available. Only one toll gate counter is available. Then automatically like. So definitely performance issue is coming because that is your programming requirement. At a time only one thread is allowed to operate. That's why performance thing by default will be there. Okay. Remember. Clear? Any doubt about this one? Up to this? Yeah. Critical section terminology from the operating system, man. Critical section terminology from the operating system. Okay, make sure. Up to this? Any doubt? Okay, now you got some basic idea. Once we are converting into the program, then you can able to enjoy like anything. I'm sure. Just at least lock concept you should aware. The remaining things, whether you are getting or not, don't worry. But this one must be required. Same example. I don't want multiple threads at a time to execute this wish method. Okay, assume that this is about my requirement, right? What I will take here is let me create one lock object. Lock is equal to lock. Let me create one lock object. I'm creating lock object, sir. After creating lock object, this for loop should be executed by only one thread at a time. So until first thread completing for loop 10 times, second thread should wait. Are you getting? Second thread should wait. Something like it is a critical section. Are you getting? Until completing first thread, okay, second thread should wait. Assume I have that requirement. What I will take here is Here, can you please guide which line I have to take? Ayo, I forgot. Which line I have to take? Which line I have to take? All the people, can you please respond? I forgot. Now onwards, if any code, this code is going to be executed by only one thread, L dot acquire. Good. L dot acquire. Now, the first person who is coming, he may come Dhoni or he may come Kohli, no problem at all. The person who came there, sir, that thread got the lock. Now, sir is going to execute. Observe that is keep on executing. Like now I'm taking L dot release. Once sir, this person is going to release, then only this lock is available for the next person. Remember this one, sir. Then only this lock is available. Now, sir, I can use the word, this code will be executed. This code will be executed. Remember that by how many threads? This code will be executed by how many threads? Only one thread. Remember that the person who got the lock, only that person is allowed to execute this one. Clear? Everyone can able to understand? Any doubt about this terminology, sir? Okay. Now take a bit very special care. But anyway, 10 seconds I don't want unnecessary. Sir, anyway, sleep is not responding here. Okay. Now observe that a bit carefully, sir. Py test.py. Good evening. Sleeping for 3 seconds. Dhoni. Good evening. Second time onwards it is not responding. Directly it is. Yeah. Someone is telling to delete the end. Yes, in print. I will delete that. Don't worry. But here just observe our requirement. Have you observed, right? Dhoni is printing properly. What the Kohli is doing? Kohli is waiting. Until what time is going to wait, sir? Until Dhoni thread is going to complete. Getting right? Now, have you observed, right? Sir, at a time, how many threads are going to be executed? Only one thread is going to be executed. Then automatically, my inconsistency problem by default got solved or not? Array inconsistency problem by default got solved or not? Yes? Remember, earlier, if this locking mechanism is not there, then automatically a bigger problem by default is going to come. Remember that, sir? Okay, bigger problem by default is going to come. Next, which thread is going to get the chance? First, we can't expect. It is varied from, sir, PVM to PVM. Okay, it is internal thing. Whether Dhoni is always getting the chance or Kohli is always going to get in the chance first, we can't expect. Remember, we can't expect. Okay, here Dhoni is getting the chance. There is no guarantee. Sir. Suppose assume that which thread is going to get in the chance. We can't give the guarantee. Suppose assume that there are T3 and T4. Can you please tell any other Dhoni, Kohli, next and after that? Yes, Raina, next Parda. Yeah. Okay. Yeah. Ambatride. Okay. Like, sir, T1, T2, T3, T4. Are you getting T1, T3, T3, T4? Like this I'm taking, sir. Now, here just observe that. Yeah. Let it complete. Now, total how many threads are available, sir? 4 threads, sir. Are you getting? Now, 4 threads by default will be there. Yes, sir. Let it complete. 1 minute. Yeah, keyboard interrupt I did. Yeah, can you please observe that? Good evening. Now who is going to come? First Dhoni. Okay, well, next whether Kohli is coming or Raina is coming or Parda is coming, I don't know that. Let's wait until Dhoni completion. In the same order the threads are going to start, no guarantee. Especially in Java, we we saw. Next, actually according to our flow, Kohli has to come because I used T2 dot start. If the Python follows first come first serve, which algorithm it is following, we are not sure. Now, have you observed Kohli only came? As per order, Kohli only came. Is it follows first come first serve? Maybe there is no guarantee for that. After Kohli, then automatically only one person, Reina or Parda. Yes, Kohli almost completed. Yes, after this, the next. So Reina is coming. So in the same order it is going to cut, but there is no guarantee for the order. Remember. So now everyone, I hope, can able to see yes. As of now, it is the first in first out order. No guarantee for that. Don't worry. So now everyone as of now can able to understand what is the meaning of synchronization. What is the meaning of at a time only one thread execution? Any doubt? Any doubt? Clear, right? Are you seeing practically also? Yes. Okay. So that's all this is. Next, there are some small things are there, sir. Just observe a bit very carefully. Here, what is that? Suppose first person got the lock. Now he is not releasing the lock. What will happen? I never checked, sir. What will happen? Observe that he got the lock. He got the lock. He is not releasing. But Vishmetar completed. Once Vishmetar completed, now this T1 is going to dead. Then what will happen to that lock? A person holding a locker key, but he dead. What will happen? Whether that key is available for the remaining or the key will be gone with that person only. If the key will be gone with that person, what about remaining his family members? We will check. I commented that release. Yes, just yes. We will check that option. Before the thread is going to dead state, is it going to release that key automatically, or we have to call explicitly? New key is created. Onkar, have you observed? Have you observed? Dhoni completed 10 times. Dhoni already dead. Dhoni already dead. Okay. Now, I mean, so Dhoni thread already dead. Okay. Now, what about remaining? Kohli, Raina, Parda waiting to get that lock. But Dhoni thread already dead without releasing the lock. Then automatically, how much time Parda Sardi is going to wait? Are you getting the remaining? Yes. Okay. That's all. Then automatically what will happen is the program is going to be halted. The program is going to be halted. If any program is like this, then automatically the problem is going to come into the picture. Yes. Is live. Definitely that thread is going to dead, man. Yes. Definitely that thread is going to dead. I'm sure. Time dot sleep off. How much time? How much? Here 10 into 3, 30 seconds. 30 seconds. Okay. Now I'm changing to 2. Next and after that, okay, 2 seconds, 20 seconds. Sir, this person is going to, main thread is going to sleep. Now print off. What is the method? T1 dot is alive. Let me cross check. Sir, after, are you everyone observing the scenario what I'm doing? Sir, have you observed? Synchronization, data inconsistency problem, all the things already we completed. Now what I'm doing is, if a person got the lock but he didn't release, what will happen? What will happen? Now this person dead, but he's not releasing the lock. That's why the remaining people are not getting the chance. Okay, like this. Now my question is T1 dot is alive. Like this, I'm calling sir. Now main thread, this line executed by main thread, no problem. Main thread won't require the lock. Again, main thread won't require the lock. That's why main thread can continue, no problem at all. Here just observe, main thread won't require the lock. Main thread won't require the lock. Observe that. Won't require lock. That's why continuing its execution line. Now, can you please tell? Now the program got hanged. How I can stop this one? First, sir, can you please tell? The threads got blocked. Control, Control C is not going to work. Compulsory. I'm typing Control C. Control C. I'm typing. It's not going to work. What is the way? Control C is not going to work. Control Z. Control Z won't work. It's a very, very important. How you can stop? How you can stop? How you can kill the blocking thread? Okay, in the Windows operating system, control break. Control break. Break is the command. Control break we require to use. Okay, remember that. Control C won't work. Where is the control break in our keyboard? Yes, pause, break, something is there, right? Pause, break, and so on. Control break. Okay, like a control break. Remember that. Now it's working. Sir, at the top, print screen, scroll, next pause or break, like there is something is there. Control Z is not going to work. Don't worry. Control break you require to use. Okay. Now have a look once. Sir, is really Dhoni thread is dead or not? After completing, my main thread is checking its status. 10 times got completed. Main thread another 5 seconds. Yes, main thread won't require lock. Next, main thread is asking, is alive or not? What is the answer we are getting? What is the answer we are getting? False. We are getting Anil. Observe that. False. False means what? False means what? This thread is alive or not alive? This thread is alive or not alive? Dead. Dead. Oh, a person dead without giving the lock, then all the remaining people gone. All the remaining people should wait. Okay, sir, dangerous problem is there. That's why whenever you are calling acquire, compulsory you should call release. Otherwise, the cinema is going to be reversed. Observe that. Okay, clear, right? Next, one more small chota observation. It is also very important. Sometimes maybe in the interview room you can ask. Here, just observe. Sir, I thought giving release, it goes to the main thread. No, no. Sir, sir, Vijaya, can you please? Sir, without giving release, it goes to main thread. No, 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 no. Here, once we started a thread, it is a separate flow again. It is a separate flow again. Observe that. It is a separate flow again. Here, how many flows are there? Actually, main flow is there. Main flow created 4 child flows. 4 child flows under the main flow as it is. Are getting? Once we started there, it is a separate flows. Main thread, why main thread is sleeping for some time? I'm waiting until Dhoni thread completes its for loop of 10. Sir, 10 times. Just now. Sir, my main thread, what it is going to do? Sir, it won't require the lock. That's why it is checking, is it alive or not? Okay. Up to this is the clear? Though it is not released the lock, thread is alive. No, thread is already dead. Which thread dead? Which thread dead? T1 dot is alive. Is alive false means it's already dead. Without releasing the lock, that person dead with the lock only. Now that lock is waste. For the remaining people, it is not available. Getting? Yeah. That's all, sir. This is again. What key I have to press? Can you please spell out? I forgot. I want to stop this flow. What key I have to press? Control break. Remember. Yeah, we can lock main thread. Any thread can able to be locked. No problem at all. Because where I write this line I write inside which method. Which method called by which persons? Which method called by which person? T1, T2, T3, T4. But main thread is not calling which method. That's why main thread won't require the lock. Observe, a bit very dangerous concept. More concentration must be required. If you are having any doubts, please, I will clarify. Don't worry. Okay, sir, that's it. Just last one more thing I want to do, sir. One more thing I want to do, sir. I want to create a lock. Anyone, can you please tell what is the code? L is equal to, respond. L is equal to, I want to create a lock. L is equal to lock. Excellent. Sir, I want to acquire a lock. A thread wants to acquire a lock. Can you please tell what is the code? L dot acquire. A thread want to release. A thread want to release. What I have to do? L dot release. L dot release. Like the API is clear. Now I'm taking a small chota program. Observe carefully, sir. I'm waiting. I'm writing a small chota program. Okay, let me save this code. Of course, here just observe that, sir. From threading, here say this one, L is equal to lock. This line executed by which thread? Can you please tell? This line executed by which thread? Your respond, which thread? Main thread. Main thread created lock object. Now observe my words very carefully, sir. Now print of main thread acquiring the lock. Main thread acquiring the lock. Like this I'm taking. L is equal to lock, main thread acquiring the lock. Okay, well, now how it is going to acquire? Acquire. Now main thread has to release the lock. Correct, right? Print of main thread has to release the lock. L dot release. Sir, just acquire and then release. And then release. That's all. Acquire and then release. Sir, which thread acquiring the lock? Main thread. Which thread releasing the lock? Main thread. Remember this one. Main thread releasing the lock. Releasing the lock. Why I'm telling this thing? Very important point is there, sir. Observe that. Perfectly it's going to work. Don't worry. Yes. Main thread acquiring the lock. Main thread releasing the lock happened. Sir, I commented these two lines. Main thread not acquired. Main thread not acquired, but main thread trying to release the lock. Then what will happen? Are you getting the point, right? Without acquiring the lock, I'm trying to release the lock. Even in Java also, do you know it is a bigger error? Okay, if we are just what will happen, sir? We will get sir, runtime error saying releasing unlocked lock. Oh, you didn't acquire the lock. How you can able to release, man? How you can able to release? Now observe that. Have you observed runtime error saying release unlocked lock? You are trying to release unlocked lock. You didn't lock that, but how you can able to release? Like it is asking. Everyone can aware? Are you able to understand? It is also one important point, sir. Without acquiring the lock, don't release. Once you acquire the lock, then only you are allowed to release that. Otherwise, we will get runtime error. That's all. Okay. So this is about a small chota concept of synchronization. How you can able to do that? Okay. You should have clear clarity about this terminology, right? Okay. Next, sir, what problems are there with this traditional locking? What is the need of going for RLock and the semaphores? That part I will discuss. Just take few minutes break. Time, I hope already you people aware what is synchronization, what is the data inconsistency problem, how you can able to solve this problem with the lock concept. That's all. More enough about synchronization. But still the people who are very much interested, sir, I want to know about the remaining things also. Can you please explain? Like if any person is there, then we will come up with the next level synchronization mechanisms. Okay, remember that. So now we have lock concept is there. Okay. Why we should go for RLock? RLock concept. Again, very simple. If one concept is there, but still another concept is there means there are some problems are there with this lock concept. Regarding there are some problems are there with this lock concept, right? So to overcome these problems, we should go for RLock. Are you getting that? Now the point is, what problems are there with the lock concept? That thing you people should aware, right? Okay, very very simple terminologies are what problems are there with the lock concept. Here, just observe the scenario. What I'm trying to do, sir. Here just observe from threading import start. Okay. L is equal to lock. I am creating the lock. Now print of, here just observe that main thread trying to acquire the lock. Main thread trying to acquire the lock. Like this I'm taking, sir. What is the code I have to take? Can you please spell out? Can you please tell? I want to write the code. What is the code I have to write? I want to main thread want to acquire the lock. L dot acquire. L dot acquire. Okay, well. Now main thread got the lock. Now print of main thread trying to acquire. Main thread trying to acquire lock again. Are you getting? Main thread trying to acquire lock again. L dot acquire. L dot acquire. Sometimes what will happen is recursive functions. Regarding there are some recursive functions. Same function we require to execute multiple times. Regarding same function we require to execute multiple times. Then the same thread may come across L dot acquire multiple times. Correct, right? Okay, multiple times. So same scenario. Best example here. Just observe a small. Just observe. Here I have some def f1 function is there, sir. Now L dot acquire. Now, sir, the thread got the lock. Next and after that, here just the here what I'm taking, sir, result is equal to f1 of n minus 1 f1 of n minus 1 something like into n something like I'm taking, sir. Assume that into n something like I'm taking. Assume. So now here the thread again calling f1 function. Are you getting right? Inside f1 thread again calling f1 function. Again calling f1 function means same thread l dot acquire again l dot acquire again l dot acquire may be a chance. Correct or not? Yes. Are you able to understand, right? Recursion function inside a function. If I use l dot acquire, so recursion multiple times this function is required to execute. Same thread trying to acquire. Same thread trying to acquire the lock multiple times. Correct or not? The same thread trying to acquire the lock multiple times, right? Okay. Sir, how you can able to do? Yes, here the same. Main thread trying to acquire the lock again. Sir, do you have such a type of requirements or not? Can you please observe? Same thread is trying to require the same lock again and again. Is it have such a type of requirements or not? Best example, recursion functions. Recursion functions, yes, there is a possibility, right? Yes, same thread is required to get the lock again and again. Requesting, even that lock is there, but requesting again and again. Sir, if requesting again and again, what will happen, sir? Now observe that after completing, okay, sir, just say last l dot release and so on. Let me execute this code. Let me execute this code. Can you please tell what is the output you are going to get? What is the output we are going to get? Sir, lock object created. Main thread trying to acquire the lock. Main thread got the lock. Main thread got the lock. Under then, main thread trying to acquire the lock again. Main thread trying to call the L dot acquire again. Can you please tell if the code will be continued to execute or not? Yes. Print main thread acquire same lock again, like this I'm taking, sir. What is the output by default you are going to get now? Please respond. What is the output by default you are going to get now? Sir, if this program is going to complete or won't complete, that's about my requirement. If you are able to understand this one, what is the need of going for RLock, you can able to see. What is the need of going for RLock, you can able to see, sir. Very simple. That is what the only one word. What is the need? What is the difference between lock concept and RLock concept? Any doubt? Okay, make sure, sir, make sure. So in the case of lock, the biggest problem is the standard lock object does not care which thread currently holding the lock. Array, this lock is held by which thread? No such type of tracking mechanism. So if the lock held and any thread attempts to acquire same lock, then automatically what will happen here? It will be blocked, sir. Array, there is no mechanism. Who is the owner of this lock? L.dot acquire. Who is the owner of this lock? No mechanism. No mechanism. That's why even the same thread asking again, sir, simply, hey, this lock already acquired. This lock is already acquired. Sorry, man, you have to wait. So, array, the same thread only got the lock, but still this normal locking mechanism, normal lock concept doesn't track who is the owner of the lock, who is currently holding. Such a type of tracking is not there. Then automatically L.dot acquire. Boss, this lock is already acquired by some thread. I don't know which thread, but please wait until that person releasing the lock. Then automatically what will happen? The program just simply halt. Or again, the simply hang. Observe that. Observe that here I am doing a small mistake. Don't worry, syntactical thing. Don't worry. Here just observe that main thread trying to acquire the lock. Yes, main thread got the lock, sir. Main thread trying to acquire lock again. Sorry. Immediately Python virtual machine is going to tell, sir, this lock is already acquired, man. Please wait until releasing the lock. Who acquired this lock? Can you please tell who acquired this lock? Same thread only, but who is the owner and so on? There is no such type of tracking mechanism. There is no such type of tracking mechanism in the simple lock concept. Remember that. Are you able to understand? If this problem is there, how you can use the multi-threading concept in the recursion functions? Are you getting it? So there are some recursive functions are there. How you can able to use multi-threading concept? Sometimes nested resources are there. Sometimes nested access to resources. Nested access means again I will ask that resource again and again. Sometimes you may have nested access to resources, recursion functions. If you want to implement, sorry, simple lock concept is going to fail. Are you seeing the problem? Everyone can able to understand the problem? Yes, here that is the bigger problem what we have in the above program. The main thread will be blocked because it is trying to acquire the lock second time. Here there is no way to identify which thread hold this lock. That's all, sir. Anywhere L.dot acquire, already lock is acquired by some thread. Which thread? I don't know that. Which thread? I don't know that. If the same thread is asking again also, sorry man, sorry, already acquired, please wait until this person releasing, then our program is going to halt. Clear, right? So if the thread calls recursive functions or nested access to resources, then the thread may try to acquire the same lock again and again, which may block our thread. So while implementing recursive functions, if a thread calls a recursive function, or if a thread wants to perform nested access to resources, then automatically a traditional lock mechanism is not going to work out. Clear, right? To overcome this problem, we should go for RLock concept. What is that concept? Can you please tell? What is that concept? RLock concept. What is the meaning of RLock, sir? RLock. Anyone can you please tell? Array RLock. What is the meaning of RLock? Can you re-entrant lock? Are you getting re-entrant lock? Re-entrant lock. What is the meaning of that? Re-entrant. Re-entrant means, sir, again and again, something like again and again. Sir, a thread can acquire the lock again and again, any number of times, no problem at all. So if you have that kind of capability, then we should go for what? Re-entrant lock. Remember that. So now what is the need of going for re-entrant lock? Now that terminology is very clear, right? Okay, re-entrant means the thread can acquire the same lock again and again if the lock is held by other threads. Are getting held by other thread, then only thread will be blocked. Remember what is the meaning of this one? What is the meaning of this one, sir? Sir, suppose T1 acquire the lock. T1 and T2 is there, sir. Assume that T1 and T2 is there. T1, sir, L.dot acquire. Assume that L.dot acquire. Sir, L.dot acquire. So first time L.dot acquire. Second time L dot acquired, assume that, sir. Legend this one a bit carefully. T1 came, sir. T1 got the lock. Now again T1 is asking, T1 is asking L dot acquired. Then immediately what will happen is, internally, if this is the reentrant law, who is the owner? Who is the owner of this law? T1 only. Who is the owner of this law? T1 only. That's why if it's the same thread, no problem, hold that. If it's the same thread, no problem, hold that. Like this we are going to use. Okay, we are going to use, no problem at all. Sir, if other thread is requesting, sorry man, this thread is already held by, this lock is already held by T1. Make sure, sir, the same thread can acquire the lock again and again. But if the different thread is coming, compulsory different thread should wait. Remember, if your thread wants to call recursive functions, if the thread wants to call recursive functions, nested access to resources, then automatically we should go for this RLock concept. Everyone can able to understand, right? Okay, same example with the RLock. I want to do that, but before that, how I can kill this one? Please tell. I forgot how we have to kill this one. I want to kill this process. Can you please tell what is the way? Control break. Regarding control break, we require to use, sir. Remember that, sir. Same concept I want to implement by using RLock. RLock concept. What is the way? RLock. Regarding RLock, remember RLock, main thread trying to acquire the lock. Now I created RLock object. Sir, same main thread trying to acquire the lock again. What will happen, sir? What will happen? Have you observed, right? Are you in a position to understand? Yes, main thread trying to acquire the lock. Main thread trying to acquire lock again. Main thread acquires the same lock again. Like any number of times thread can acquire the same lock again and again. Okay, that's what you people should aware. But anyway, in this example I didn't release. But in reality, compulsory we should release. Remember that. So what is the benefit with this? So Vijaya, just one small example I will go for, so that you people can able to understand. I hope. Yeah, don't worry, just wait. Yes, clear for all period. So sometimes what will happen, to call recursive functions, to call access to nested resources, compulsory we require to go for what? This lock. Remember. Clear, right? Yes. Further, your doubt without releasing also, it came out for our lock. Here the reason is, any other thread waiting for the lock? No, right? Any other thread waiting for the lock? No. That's why the program got terminated. If any other thread waiting for this lock, definitely the program will be halt, will be hanged. Clear, right? Sir, that's all. This is about RLock and lock. Sir, just let me explain just 1 minute. What is the main difference between lock and RLock? Can you please, with this knowledge, can you please spell out? What is the main difference between lock and RLock? Lock concept. Okay, lock and RLock. Lock, a thread here. In the case of simple lock, there is no tracking mechanism which thread holds the lock. Are you getting? But in the case of RLock, there is a tracking mechanism which thread holds the lock. Who is the owner of current lock? Okay, there is a tracking mechanism. So here tracking mechanism is not there. Because of that, in the case of lock, if the same lock asking again, trying to acquire the lock again, then it will be stopped, because there is no way which thread hold. Suppose main thread hold the lock, hold the lock. Second time the same main thread is asking again. Sir, here no tracking mechanism saying which thread hold. Sir, already this lock is acquired, please wait. Even the same thread also, it has to wait. But in the case of RLock, sir, there is a tracking mechanism. If this person is the same person, yellow like this, right? If this person is the same person, yellow like this, right? So in the case of RLock, tracking mechanism is there, who is the owner, like this, right? Okay, now, so it's better directly go to RLock, irrespective of conditions. We should go for lock if there are no recursions, which is a good way, sir. Remember that, for if you have recursion, better to go for RLock. If you are not having the recursion, If you are not having nested access to the resources, better to go for lock only. Remember that. So Nandakishore, the problem here is, if suppose a small, I required in my office attender, I required in my office one expert faculty also. So anyway, faculty also can do attender job. Can I recruit faculty in the place of attender? Not recommended. Regarding not recommended. If you want to attender, then we should not go further. Regarding that, okay? Same kind of thing. RLock is a very costly. RLock is a very costly. Compulsory we should go for normal lock only. If you have recursion, if you have nested access, then only we should go for RLock concept. Clear, right? Yeah. So now, but in RLock also, thread is holding the lock, and even it's asking for lock, and Python will provide the lock. Yes, yes. So multiple holes on the same lock is possible, but the problem here is, sir, multiple holes by the same lock or by the different lock. Omkar, just observe. The remaining people also, Omkar's doubt is, have a look once. Sir, but in RLock also thread is holding lock, and even though it is asking for the lock, and Python provides the lock. Sir, multiple sir holds by the same thread only. If a different thread is coming, then that person has to wait. Omkar, getting the point right? If the same person, if the person is the same, if the thread is the same thread, then only. If the thread is not same, different thread, then automatically that person also should wait. Okay, like more meaningful example I will discuss, so that you people can get much clarity about this one, sir. So let me go for one RLock concept where you can able to use. Just observe that. But before that, one small point you people should be aware. Now observe how to create RLock object. Can you please tell the way? I respond. How to create RLock concept? L is equal to RLock. Are you getting? L is equal to RLock. How you can acquire a lock? L dot acquire. L dot acquire. How many times I can call L dot acquire, L dot acquire, L dot acquire? Multiple times or not? Respond, man. Multiple times can I call or not? Yes. Can I call the same in the case of normal lock? No. No such type of possibility, right? In the case of normal lock, you can't. But in the case of RLock only, we have this type of facility, right? Now, listen very carefully. First time, thread calls L dot acquire. Now the thread got the lock. Regarding thread got the lock, acquires the lock. How many holes are there? Number of holes is nothing but one. Number of holes is nothing but one. Same thread is asking again. Then automatically number of same. Here only one lock only. Sir, it's already acquired. Just simply number of holes is nothing but 2. Already had the lock. Number of holes is nothing but 2. That's all. It won't get the lock second time. Are you getting? That lock is only one only. Already the same thread. That's why hold count will be increased. Number of holes is nothing but what? 3, sir. Remember that. Number of holes is nothing but 3. Like this. Now my question is, observe that. I'm calling L dot release. Very, very important. L dot release. Can you please tell lock will be released or not? Please respond each and every person. Sir, a bit difficult concept only. Please, the people who are unable to think, you can ignore this concept. Don't worry. Yes. Can you please tell L dot release? Is the thread, is the lock will be released or not? Okay. Remember that. Here, the lock won't be released. Number of holes will be reduced. 3 minus 1 is nothing but 2, sir. So again I'm taking L dot release. Then 2 minus 1 is nothing but 1. Next again I'm using L dot release. 1 minus 1 is nothing but 0. Then only the lock will be released. How many times you call acquire method? Those many number of times you require to call release method. Remember that, sir. If there is a mismatch in the number, then the lock won't be released, sir. Every time you call acquire, hold count by default will be increases. Okay, like next hold count by default will be increases. If there is no, every time we are calling release, hold count by default will be reduced, sir. Whenever hold count is the 0, then automatically, then only lock will be released. But remember that how many locks are available? How many lock objects are available? Respond, Omkar. How many lock objects are available? Only one lock. Only one lock. Only one lock. But how many, sir, holes are available? Multiple holes. Okay, like this. Clear? Now let me go for one small scenario where RLock compulsory you require to use. You should not use a normal lock concept, right? I will go for a small chota example, then you people can feel more comfortable, I'm sure. Observe that. Observe a bit very carefully, sir. Sir, I'm taking here, just a legend. I'm taking, sir, here import time, because already you aware. Next, L is equal to RLock, like this I'm taking, sir. L is equal to RLock like I'm taking. Now I want to define one function, sir. Df factorial of n. I'm defining my own function, factorial of n. So this factorial function should be executed by only one thread at a time. Assume that this function should be executed by only one thread at a time. What I'm taking, sir, L dot acquire. L dot acquire the lock, because already lock is there with me. L dot acquire the lock. Next, if n double equal to 0, if n value is the 0, if n value is equal to 0, result is equal to 1, I'm taking, because factorial of 0 is always 1, else result is equal to, do you know, result is equal to, sir, what you can, n into factorial of n minus 1. What is this function? Anyone, can you please tell what is this function? This function is nothing but one recursion. Inside factorial, I'm calling again the same function, recursion. So here observe, again same function is required to execute, means again same thread trying to acquire the lock, remember that. Okay, like this. So now after this our job completed. L dot release the lock, and then return result. Release the lock, return result, like this I'm taking, sir. That's all. Now what I want to take is, sir, just very simple, sir. Results of n, like this I'm taking. Def one function I'm taking, sir. Results, just have a look once. Results, I'm taking one more function, results of n. Okay, print the factorial of n is, sir, print the factorial of n is, the factorial of n is, okay. What is the factorial of n, sir? Just I'm calling factorial of n. That's all. This is the results function. So a thread has to call this results function. Results function internally calls factorial, like this, right? Now let me take t1 is equal to thread of target is equal to results. Okay, like I have to take results function, comma, args is equal to just a 5. I want to find the factorial of 5. Are you getting? Like, sir, t2 is equal to, sir, args is equal to factorial of 9, I'm taking t2, like this, right? Next, t1 dot start, t2 dot start, t1 dot start, next t2 dot start, like this I'm taking, sir. Just t2 dot start. Okay, like I'm going to take. Sir, now take very special care about this one. In this case, assume t1 executed first. Assume t1 got executed first. If t1 got executed first, t1 got the lock. If the t1 got the lock, again this function will be called, because it's the recursive function, right? Same thread can call again, same thread can call thread again. Then automatically, how many times thread has to acquire the lock? How many times the thread has to acquire the lock? Multiple times. Are you getting? Multiple n number of times thread has to acquire the lock. Then automatically, so do you know, RLock concept is the best choice. If you go for normal lock concept, then automatically maybe a problem, sir. Remember that. Yes. I mean, in case of factorial method, if LDOT acquire more than once, then by calling LDOT release only one time, won't release the lock. Correct. Correct. Yes, so that's why here every time LDOT acquire, every time LDOT release. Remember that. Every time LDOT acquire, every time LDOT release. Okay, like, yeah. Now just observe a bit carefully about this one. Yes, Amit, observe that. I will show. Don't worry. Here T1 dot start and so on. Just the factorial of 5 is 120. The factorial of 9 is 3,62,880. Like this we have. Now my question is, how many threads are there? Please respond. How many threads are there? Two threads are there. Two threads are there. Remember this one. Two threads are there, including main. Forget about that. Two are there. Now first thread calling results method. Results method calling factorial of n. Now factorial of n, factorial of 5. Then as it is the recursion, sir, again and again it has to call means factorial method should require to execute around 5 times. Around 5 times, thread is always asking LDOT acquire and so on. In this type of scenario, compulsory we should go for RLock only. If it is not RLock, if it is a normal lock, first thread already got the lock. Same thread, because of this factorial function, it is calling again. Same thread is asking the lock again. Sorry, man, this lock is already locked. I won't give there is no chance. Please wait. Like your program is going to be hold. Your program is going to be halt, sir. Just observe that. Observe. It is the RLock. It is the RLock. Definitely, happily it is going to execute. No problem at all. Remember that RLock. Happily it is going to execute, sir. Now my question is, let me remove this R. Let me remove this R. Can you please guide? Is it going to work or not? Can you please guide? Is it going to work or not? Yes, what will happen? Am I going to get any error? Am I going to get any error? Yes, no error, no error. Immediately the program just simply hangs because the same person requesting lock again, same person requesting the lock again and again. Okay, like now observe that. Are you in a position to see the difference? If you have recursion functions, sorry, your lock concept is not going to work because in the case of recursion, thread trying to acquire the same lock again and again. Yes, Parthas are there. Yes, there is a deadlock scenario also. Clear? Correct. Why this problem is coming? Why this problem is coming? Because in the traditional locking, there is no tracking mechanism. Who acquires the lock? Who acquired the lock? Even same person coming. Sorry, you have to wait. Sorry, you have to wait. There is no tracking mechanism, which is, but in the case of RLock, tracking mechanism is there. If the same person is asking, array, same person only, no problem, hello, no problem, hello, like this, right? Suppose sometimes assume in the park or otherwise, if you go to the park, if you go to the cinema theater and so on, just you already hand over the ticket, you entered into the hall. Assume that. Sir, suddenly you require to go out for the water purpose and so on. Now there is a gate person is there. Array, I will go for water. Within 2 minutes I will come. Please allow me like. Please allow me like. Then immediately that person, no problem, sir, you can go. Yes, I will go to the outside. I will go for chai. After 2 minutes I'm coming. Then immediately, if that gatekeeper can able to recognize me, then automatically my life will become very easy. Oh, same person only. Hello, no problem. Hello, no problem. If you have already some recognition mechanism is there, then you can go out, you can come, go out, you can come, and so on. But sometimes what will happen is there is no such type of recognition mechanism. Already you hand over your ticket. No mechanism. Once you go out, if you are coming again, sorry man, not allowed, not allowed. Like, are you in a position to visualize my example, my scenario? Ayo, are you able to visualize the scenario? Sir, sometimes, you know, you entered into the theater. You entered into the theater, sir. Once you entered into the theater by hand over the ticket, assume you are not having any of the ticket or coupon is not there. Just a complete ticket hand over to that person. You entered into the hall. Suddenly you want to go for water. Yes, you are going out water. Then the gatekeeper is telling, sorry, we are not allowed. We are not allowed second time. Sorry, you have to wait. Then automatically, once you entered, you can't go out. Regarding, it's always a problem. That kind of thing is nothing but okay, normal lock concept. No, owner having recognition. Sir, owner tracking is already there. Gatekeeper can able to recognize me. Then you can come inside, go out any number of times, no problem at all. Like yes, it's like person having iCard can enter again and again. But if you don't have iCard, can't enter more than once. Correct? Yeah. That's all. This is what you people should have heard. Yeah. Arpita, she is asking some small doubts, sir. No. But it could not, yeah. Yes, what is the doubt, Arpita? No, Amit. Yeah. Arpita, can you please come again? What is your doubt? Yeah, that's all. So now it is very clear for you people, right? Sir, what is the difference between lock and RLock? Sometimes maybe a chance to ask in the interview room, but a bit difficult concepts to understand. Please take a bit very special care. Now just a small table we are going to discuss. Just observe. If we write a release after T2 dot start, if we write a release after T2 dot start, what will happen? I mean, you don't want to write here, Arpita. You don't want to write here, or it is there after that L dot release. You are asking like this. Yes, 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 Nandakishore, correct. Arpita, please. You want me to write here? No, remove from the top. Correct. Hmm. Okay. And then where I have to write? What will happen, sir? What will happen? My thread trying to acquire the lock again. Now the result by default will be printed. Whenever second thread is coming, but the first thread is not released the lock, then automatically second thread should wait. Next, the main thread, there is a problem is there in the main thread also. Without acquiring the lock, main thread trying to release, then automatically is going to get runtime error. Oh, multiple problems are going to come. Three threads are there, three flows you can able to see. Control break. Okay. Now observe that. Observe. So total how many threads are there in this program? Total how many threads are there? Three threads. Arpita, three threads. Main thread mistake is without acquiring the lock, it is calling release. That's why the problem is runtime error. One flow problem is error. Okay. Next, second flow is T1 dot start. This T1 dot start calling factorial of n. Happily, it is going to provide factorial of n, no problem at all. But the main thread, what the blender mistake, I mean, what this T1 blender mistake it did is, without releasing the lock, he didn't release the lock, then it's not available to the second thread. So second thread has to wait forever. Remember that. Now observe the flow. Observe the flow. T1 dot start, T2 dot start. Here simply the program got hanged. 1 minute. 1 minute. Main thread. Keep on acquire. Sorry. Yes. We use which lock? Is it normal lock or R lock? Is it normal lock or R lock? Normal lock. That's why the problem. R lock. Get control break. Yeah. Observe that. Now it's very clear. This is by the thread 1. Thread 1 happily it is executed, but that bloody person he didn't release the lock. Remember that. That bloody person he didn't release the lock. First thing. Second thing, sir, main thread without having the lock, this person without having the lock, this person trying to release. So that's why he raised the error. Next, who is the third person? Who is the third person? T2. T2 keep on waiting. Now total how many flows are there? Are you able to understand? Total 3 flows are there here. Have you observed? One flow T1 completed, but that bloody person didn't release the lock. Next, main thread without having the lock, he is trying to release runtime error. Next, where is the third person? T2 thread. That person not acquiring the lock. That's why keep on waiting. I hope you people are able to see 3 flows. Okay, like this. Completed, man. Yeah, like you people should aware, sir. Okay, like next. Yeah, Omkar, you are asking something. Just can you please, sir? If you release release before recursive function call, before recursive function call means, can you please suggest at which line? Line number? Can you please tell, Omkar? Can you please tell some line number so that I can recognize? Program line number 1 2 3 4 after 8. After 8, before after 8, after 8 means before, if we use l dot release before recursive function call means here l dot release. Can you please tell what will happen? Can you please tell what will happen? Then the problem is, sir, there may be a chance of problem. Thread acquire the lock, and the thread release in the lock. Every time acquire and release. What will happen? Once acquire and release, meanwhile, second thread may get the chance. Regarding second thread may get the chance. If these variables are global variables, then automatically those global variables by default will be updated by the second thread and so on. Inconsistency problem may come in the picture. Okay, inconsistency problem may come, but luckily here I'm using only local variables. That's why you may not get the problem, I'm sure. But if the global data is there, then automatically the problem is going to come. The factorial of 5 is 120. Next and after the T2 already started. L acquire, and then L release. Whenever we are taking factorial function, L acquire like this. So just trace what happening. L1 is already completed, but L1 last time it is not going to release the lock. Correct. Yes, Omkar, are you seeing the problem? Omkar, are you able to see the problem? Yes, the problem is you are calling release inside else. But last scenario, when this factorial is going to be stopped, sir, whenever n is equal to 0, then only. At that time, release is not going to be happen. T1 is not going to release. Then what will happen? T2 will, okay? T2 has to, T1 not releasing, T2 has to. Then what you have to do? L not release, here also you have to keep. Yeah. No problem. Okay, friends. Anyway, sir, take a bit very special care about this one. That's all. This is about RLock and RLock. A bit dangerous concepts. Please take a bit special care. If any person is asking what is the difference between RLock and RLock, just a matter of 2 minutes. Let me summarize so that we will go for next level. Lock and what is this one, sir? RLock. Lock and RLock. Normal lock and RLock. Observe that. Sir, lock object can be acquired by how many threads at a time? Can you please tell? Lock object can be acquired by how many threads at a time? Please respond. This lock can be acquired by only one thread. Regarding only one thread at a time. Even owner thread also can't acquire multiple times. Owner thread also Can't acquire. Owner thread means the person who is already having. Can't acquire multiple times. Can't acquire multiple times. Are you getting multiple times like this, right? Next, here RLock. Here RLock. Have you observed, right? So RLock object can be acquired by only one thread at a time, but one thread can acquire multiple times, multiple holes. Okay, multiple holes. Remember that at a time only one thread only, but a thread can keep multiple holes, no problem at all. Okay, remember. Next, the second. So do you know not suitable to execute recursive functions under nested access calls. Recursive functions. Are you getting? If you want to do recursive functions under nested access functions, not suitable, not suitable. But here, this one is nothing for recursive functions. It is the best choice, right? Okay. If a thread calls recursive functions, compulsory we should go for RLock concept. Next, in this case, lock object will take care only locked and unlocked. It never takes care about owner thread and recursion level. Are you getting right? In this case, so tracking mechanism is not there. Who is the owner? Who is the owner? And next and after that recursion level, such type of terminologies are not there. But in the case of RLock, do you know? Sir, there is a tracking mechanism. Who is the owner? Who is the owner? How many number of times number of holes are available or number of recursion level by default we can able to identify. This concept is nothing but RLock underlock concept. Everyone can able to understand?